in particular, we're going to start on functions here. Like C, functions can exist in the global space, or they can be scoped down to a module, or they can be scoped down to a class. We will be looking at classes in Python. But we'll just go ahead and start with simple functions where you're putting them in you're putting them in the global namespace, or at least the script namespace here. To define a function, you use the keyword def, right? And then you give the function a name. So you don't say that this is a function. The syntax itself is going to declare that this is a function. So I don't know. We'll call it foo for lack of a better name here. First of all, can everybody see that in the back, or good? Or okay. All right. So and then to declare that this is a function, you put in parentheses here. All right. And then what is the function? Instead of opening and closing curly brackets, you use a semicolon. Now, anything that you put inside this function using indentation, that's part of the function. The second that you go outside of that indentation, it's no longer part of the function. It's part of the regular script. All right? So let me go ahead and come back over here. And let's actually print out what this function does. Print hello for now. Right? It automatically prints the end line character, so we'll just go ahead and do this. All right? Now down here, you can go ahead and print and call foo. Right? Let's go ahead and run this. And it just prints out hello because it calls that function, and then that function actually prints hello. But this will also work, I believe, I hope, because, oh, nope, it doesn't. All right, darn it. All right, some languages, and I'm misremembering Python here, some languages do what's called hoisting. So, for example, Python does this, and JavaScript does this, where it will go through a script and find all the functions and then hoists them up to the top so that you don't have to put all the functions and define the function before you actually use them. In C, you use prototypes. In Java, it also doesn't matter because it's part of a class. So the class gets compiled, it already knows that the function is there. But apparently the order does matter here. If you're going to call that function, you need to define it before you actually call it. Okay? What if we wanted to pass something in there, right? Say we've got A is equal to 10, B is equal to 20, and C is equal to 30. Okay? Let's go ahead and pass all of those in as arguments, A, B, C. Right? Hello, and then we'll go ahead and say Z or X is equal to A plus B plus C. Right? And then we'll print in a formatted manner X is equal to X. There we go. Now let's go ahead and call this with A, B, and C. Okay? So 10 plus 20 plus 30, what should the expected result here be? 60, and it is. But what happens when I refuse to give it the correct number of arguments here? Let's find out. Right. It's missing 1. Okay. Many languages, many dynamically typed languages, where the types themselves are dynamic. So is this an integer? I don't know. Is this a string? I don't know. What are they, right? For example, I could come down here and change all these to hello, right? World, exclamation point, exclamation point, exclamation point. Pass those in, and now is the result going to be 60? Nope, oops, too many quotes there. Nope, it's going to be hello world all concatenated together. Ooh, here's a good question. What's going to happen if I put in a mixture? 10, an integer, and then world, and then C. What happens when we try to take an integer and add a string? Those two are incompatible. So this is going to be an error, right? Yep, there we go. You cannot add two different types using the plus operator in Python. So at first it's, well, there's no type safety here whatsoever. And this is one of the consequences of dynamic typing. If there is no integer, a declared integer, if there is no declared double, if there is no declared string, then these could be whatever you want, right? And enforcement of those types then becomes a manual process, right? If type of A is not int, then I'll throw a new exception or print error expected A to be an integer. I don't even know if this is going to be correct syntax or not. but I'll go ahead and give it hello again. Okay, yep, oh, good. Wow, cool. It's not an integer, right? It's a string. And so it's going to end up being error handling with respect to stuff that a compiler would take care of, now becomes a manual process, right? Let's go back to the numbers so that we can get b is equal to 20, c is equal to 30. There we go. All right. And let's actually print these down here too. Print in a formatted manner a, b, and c. All right. There we go. And up here, we're going to also add them up and print them out. But also, I'm going to go ahead and after I've done printing them out, I'm going to try to make a change. A is equal to 42. All right. Now, in programming languages like Java and C, what would you expect to be printed on line 15? Is changing one of these variables up here going to change this variable down here, even though there's the A, B, C, right? Let's find out. If they're different variables, if this is ABC and this is ABC and these are different sets of variables, I should expect that it should still be 10, 20, and 30 because I can't change that value, right? And it is. So what does that tell you about Python? Everything is passed by default, passed by value, right? Not reference. These are not pointers, okay? There are ways of doing a list is a passed by reference, and so you can make changes to a list, but these variables are always passed by value. There are no pointers in Python, so how do you do this? I'd have to look that up. I don't even know if it's possible. In Java, it's not possible to pass by reference, right? All right, so we've got that. Here's another trick. Okay, well, I don't want to pass everything in, right? Again, this didn't work before. Oh, darn it. How do I restore my terminal? Terminal, new terminal. There we go. Lecture, CSC. Don't close your terminal. Right? I just mashed the keyboard, and that was a quick key to close the terminal, apparently. All right, so Python demo.py. Right? Remember that we're missing that third argument. In C and Java, in Java, that would also be a compiler error. You have a function that expects 3 things, you only give it 2, that's not going to work. In C, as long as you're using proper prototypes, that's also a compiler error. But in really, really old C, predating prototypes, this would have been allowed. And in many programming languages that are dynamically typed, it's also allowed. Right? As long as, in Python at least, you provide a default, 30. Right? So here's new syntax for folks. This is going to be defining a default value. If you do not provide me a C, one will be provided for you with a value of 30. And now it'll work just like before with a value of 60. Because you didn't give me C, so I'm going to go ahead and provide a default here. If you can provide a default, but if somebody provides one for you, then that takes precedence. So for example, let's say that this is 42. All right? The 20 there still takes precedence, and the summation is 60. But the second that I do not provide it, then the default takes over, and now it's 82. 10 plus 42 plus 30. Right? 30 being the default up here. You don't have to provide a default, and if you don't provide a default, then there is no default, and then it becomes an error. Or you can default to a default. None. Right? Now it's completely optional, and if you don't provide me any arguments here, then I have none, 42, and 30. What is the sum of those things? What do you think? Error, right? Because you can't take none, which is a non-numerical value, and make it into a variable, right? But you can make, if A is none, then I'll reset A to be 10 or something like this, right? Actually, no. If A is none, then I will do a summation without it. There we go. B plus C. Else. Oops. I don't know if I'm using the proper indentation here or not. Else, X. All right, fine. X is equal to A plus B plus C. Right? If you don't provide me an A, then I can't do anything with it, and so I won't even add it. You can make conditional statements like this. Now it's 72, it'll work. Perfectly fine. Yeah?
So is none kind of like the Python null
Yep. None, or capital N, none, is basically a null or null type, right? There's also none type, right? So I shouldn't say type, I should say value, right? None type is the none value, right? So if I said, what is the type of none? Is it an integer? No. Is it a double? No. Is it a string? No. What's its type? It's none type, right? So there's none and then there's none type. None and none type are not zero, right? As you see, you can't just add them to whatever, right? And that also is true for strings. Y is equal to hello. And if I try to concatenate these together, z is equal to x plus y, and then print z, I believe that this won't work either. Yeah, because none type and string, you can't do that. But you could do something like this, force it to become a string, and then I believe that when you force it to become a string, it just becomes the empty string. Let's find out. Or does it become the word none? Yeah, it becomes the word none. N-O-N-E-N-E, right? Capital N. Right? All right. So there is a function, right? Let me go ahead and put all of that in the notes so that you have it, but then I'm going to go ahead and modify it. Python. There we go. This really cool function that I wrote, I want to go ahead and modularize this, and I want to put this into a library of functions. So let's come over here to new file, my library.py. There we go. And I want to get rid of that. I want to move this really cool function over here so that it's now part of a library, okay? And I just want to use it over here. So A is equal to 10, B is equal to 20, C is equal to 30, and then I want to call foo on A, B, C, right? And then I'll capture the value there, x, and then print x, whatever that might be. How do I refer to this function over here that's outside of my current script? Well, how did we bring in a math library, for example? Import math, right? I can do the same thing with my library. Now that I've called it mylibrary.py, let's go ahead and try this. Oops, nope, foo is not defined, so I'm going to have to do something else. I'm going to have to import foo from my library. There we go. It's the opposite. From my, it's Yoda speak. From my library, import foo. There we go. Got to go backwards there. Right? So x equals 60. That's actually me printing it out over here. X is equal to 60. It's not this x over here being printed out. Let me go ahead and call it something else. Z. What actually got printed out on line 8 there? None. Why? Do you see a return statement on this function? Nope. So if there's no return statement, one will be provided for you. The default is, like all defaults, none. So I'll go ahead and make a return statement here of return x, whatever happened to be that summation. And now over here it will actually work and it'll print out 60 as well. All right. Yeah.
Do you have to import every single function from a library individually?
From a custom library, if you want to name it, if you want a direct name, then yes. From my library, no. From my library import. I doubt that this will work, but let's try it. Like this is what you would do in, say, Java. You can? Right, yeah, don't do that though. Just like you can do that in Java, don't do it here. Be more intentional, right? When you bring in the math library, you can bring in in particular function. Like, for example, let's go ahead and bring in import math. Now, I can't just go y is equal to square root of 2, print y. It doesn't know what square root of 2 is because it belongs to the math library, right? So what I have to do is I have to go, well, you brought in the math library, math dot. Alternatively, what you could have done is from math import square root. And now it will work because you've given it basically a local name, right? So, yeah, this is usual. It's still, I'd still consider it icky because you're bringing in everything. You're not polluting the namespace though, because it's hard to say. You could do the same thing over here. I think it requires a little bit more syntax, and I don't remember it off the top of my head. To actually make this into a module, you have to declare that this is a module, and so you can use this syntax of import everything, right? But as it is, you'd have to use a wildcard, something like this. I'm going to go ahead and get rid of that because wildcards are icky. It's kind of a sloppy, bad habit to get into. Doing it this way is at least a little bit better because you're still forced to scope it to math.square root, right? And there we go. And there, just bring in the math library.
Did you do my library.foo?
Yes. So let's go ahead and go with import my library and then go with my library.foo. This will work, I'm pretty sure. Yep. Yeah. So that's the way to do it. Don't do a wild card. If you're going to do it and you just want to bring in everything, do it this way. Right? Okay. Otherwise, you can import individual things because, for example, if you had two functions named foo in library A and library B, you're going to have to import the libraries, but then use the naming of the libraries to access that foo and then that foo independently. Or and if you just brought it, but if you just brought in the foo, now foo is in the scope, and you've got a conflict, right? All right. So let me bring this over and describe this as modularization, right? So this file will, what do I call this file? Demo.py would end up being Python. There we go. Oops. No, I want all of it. There we go. All of it. There we go. And then in my library.py. And you note the naming convention there. That's the Pythonic way of doing it. It could be any name that you want, regardless of casing, regardless of underscore casing or whatever. But underscore casing is the preferred way for everything in Python. All right, any questions so far? No? I'll go ahead and get, there we go. What else is there? Oh yeah, before I cut and pasted this, I should have shown you this. There we go. This is the preferred, say this, method for documenting functions, right? This is, I think, PEP 136 or something like that. PP, Python, documentation. There we go. They're called documentation strings. PEP 257 and PEP 8 style guides will dictate how this works. This is basically what you're going to do. Right? Let me come over here. This is PEP 8, documented in PEP 8 and PEP 257. Does anybody know what PEP stands for? It's like Python something something. What is PEP? What is a Python PEP? Python purpose and guide, PEP 1. Come on. I just want, what does PEP mean in Python? There, Quora. What is it? Python enhanced proposal? Thank you. So it's just a proposal for a guideline for how to go about doing something. And in this particular case, how should we go about documenting our functions, right, or our classes or whatever? And this is the preferred way of doing it. I have three, first of all, same indentation level here. That's required. But I have 3 double quotes here. And then I end it with 3 double quotes. That is not actually a comment. That is a multi-line string. You can do something like that over here, right? Message is equal to, if you've got a message that has multiple lines, you don't have to go ahead and put in manually a bunch of end-line characters. You can go ahead and put in the literal message. Hello, world, how are you today? Right. And end it with 3 double quotes here. Print message. And it will print string, that multi-line string, end-line characters and all preserved, right? So this is a multi-line string. It's also, by the way, supported in Java. It is not supported in C. This is something that was added in later Javas, like 9, 10, 11, something like that. But you can do something like this. So this is not actually a comment, it is a string. But am I assigning that string to anything? No. So it becomes a useless string, and it is effectively a comment, right? There is no multi-line comments. So there's not like, what would it look like? Something like this. It doesn't work that way, right? You only have single line comments using the hashes here, right? So if you're going to document something, then you document it like this. You can use this multi-line string and provide markdown style syntax. So for example, the A parameter is optional. Right? So if you don't know markdown, that's fine. You don't have to use markdown. But to code escape something, you use, oh, here's a good quiz question. What is that character called? It is at the top left of your keyboard, right under the tilde. It is not a quote. It is not a single quote. It's called a backtick, right? It is a tick that's back, right? Don't ask me why. I'm sure that, I mean, it's on the standard QWERTY keyboard, so it dates back to the 19th century. I think 19th century, whenever the QWERTY keyboard was actually invented. So it had some meaning at some point that is now being used in Markdown to denote code, right? So for example, the A as parameter is optional, as is B, and with a default of 42, right? Whatever documentation and C that you're going to provide, default is going to be 30 here, right? You can backtick those, and it's not going to show up here because I don't have a full environment, but if documentation were to automatically be generated, it would be stylized in Markdown. And by the way, what do you think I'm using here to do all this stuff? Markdown, right? When you look at the notes on GitHub, it's going to automatically generate the markdown, the stylized markdown for you. But if you look at the raw file, then you'll see the markdown source in there. Okay. So if you want to learn markdown, great, go ahead. But otherwise, you don't have to. You have to use name is equal to this is not useless string. Yeah, that wouldn't be useless string. Can I cut and paste this directly? There we go. So here's another way that you can do a main, right? There we go. Main, and then I don't have a main here, so def main. There we go. All right, and then I can call my function, my library, or printf, print hello. There we go. So there's a way of, don't do all of them, there we go. And that's a way that you can do a main entry point, except that it's already main by itself. Right? But if you just start running a script, it's going to be the main. Right? Okay. What else? Any questions so far? No? We'll look at functions again when we get to classes here in a moment. Right? But for now, let's talk about file I/O. Right? So file I/O. So first of all, file output. Right? Use not fopen, but open to open a file. And it's going to look very, very familiar to you, right? So f is equal to open, let's go with foo.txt, right? And I'm going to open it up for the purposes of writing, because this is file output, right? There we go. F.write, hello, how are you? There we go. F.write, I am fine. Now remember, if I print something, it's automatically going to insert that end-line character for me. And by the way, what should you do after once you've opened a file and you're done writing to it or reading from it? What should you do? F close. There we go. And let's run this. And I'm going to have to refresh over here because it did create that new file, but it's not showing up. Once I refresh, now it shows up. There we go. Once it loaded. Hello, how are you? I am fine. Is there an end-line character there? Nope. So what does that tell you about write? You got to insert them yourselves, right? So write will not insert an end line by default. You can write whatever you want. F.write a is equal to 10. F.write a. I believe you can do this. Let's find out. Nope. It's got to be a string, so you can't do this, but you can do it this way. Force a to become a string so that you can write it out to the file. There we go. Reload this. I am fine now that has an end-line character, but between I am fine and 10, there is no end-line character, so let's go ahead and add one. Or even better, you can just go ahead and use formatted strings, F strings. F.write, F, A is equal to A, neato, end line. There we go. And write that, and there we go. It's all done. Now again, I didn't put that end line character on that other one, so either print it or just concatenate. Remember that plus is concatenate as long as they're both strings. They both have to be strings. This is a string by default, and this is a string because I forced it to become a string. All right. That's file output. Why does it look familiar? Instead of fopen, it's just open, right? But it takes two arguments. The name of the file that you want to open and the mode that you want to open it up for writing. By the way, there are plenty of other ways of doing file I/O. I'm just showing you one way. Right? I think that there's a way that you can like write lines. Like so, if you've got this entire like an array of lines or a list of lines, or you've just got this one big giant string, there are alternative ways of doing it. Right? Okay. What's the other mode that we can open up a file for? Reading. Right. So let's go ahead and create a file over here. I want a different one, bar.txt, and there we go. Finally, bar, line 1, skip a few, line 7, line 8. There we go. And come over here, and we'll open it up for the purposes of reading. Okay? Here's the easiest way to do it. Lines is equal to f dot read lines. That's it. Print lines. Hello, how are you? I am fine. 10, oh, oops, foo. I wanted bar. There we go. There we go. Ooh, tell me, what do you see at the end of each one of those strings being printed? An end-line character. So it preserves end-line characters. There are ways of stripping those out. Refer to your lab for how to do that. One way of doing it is I use a regular expression to get rid of it. But otherwise, another way of doing it, strip out white space using, I think it's trim. Let's question mark that for a second here. And so what I'll do is I'll iterate over those lines. Remember, it's just a regular old for loop. For line in lines, right? X is equal to line dot trim. There we go. Print X. Let's find out if that trims it. I would expect them all to be on the same line if this works. Nope. Did I mean strip? Maybe. Python remove trailing white space. From string, yes. Where else would it be? Is it strip? Yep, it is strip. All right. Well, thank you, interpreter. Yes, you knew exactly what I was searching for. Right, there we go. So why is it still printing those end-line characters? One to a line. What does print do again, remember? It inserts them automatically for you. Right? So I can strip them out and then store them into another stripped array is equal to an empty array Instead of printing them out, what I'll do is I'll say that stripped.append x, and then down here I can say print stripped. So I'm stripping out all the end-line characters, and then I'm putting them back in the array, and you can see now that they're all gone. Right? That's 1, 2, 3, 4 lines of code. Is there a better way? Remember what we covered on Friday? List comprehensions, right? Line.strip for line in lines. Isn't that cool? A one-liner. And I get the same exact, come on, I get the same exact result here. This is a list comprehension. Stripped is going to be a list of lines stripped for each line in the collection lines. Right? Again, I don't know if you probably haven't gotten to sets in say 235 yet, but you can see set builder notation. All x such that x is even. Right? You use this set builder notation in mathematics all the time. Right? And that's basically what they're going for here. All x such that x is even and it's in the collection lines or whatever. Right? Okay. That's the easiest way. An alternative way would be f is equal to open bar.txt for reading. And then, by the way, there are ways of doing this with exception handling so that if the file doesn't open or you don't have permissions or something, you can catch that exception and deal with it. We won't get into that level of detail here, but you can do something like this. How do I do it line by line? Darn it. Now I don't know how to do the, we can do it like this. While true, line is equal to f.read line. So note up here, I read what? Read lines. Down here, it's read line, one line. And then if line is none, break. Otherwise, print line. I think this is how you do it. Let's find out. Oh, okay. Nope, it's an infinite loop. So, ignore me. I forget how to do it. We'll skip it. Besides, why would you do that when you've got this? Right? And then once you've got it in memory, close it. You're done with the file. Forget about it. Right? Process each one of those lines as you want. Okay? That's the easiest way of doing it. And the easiest way is always the best way, right? File input. All right. What's next? File input, file output, error handling. All right. So Python does have a an exception system. All right. You use the keywords try, just like Java, and but there is no catch, and there's except. There we go. So try, let's go ahead and go with A is equal to 10, B is equal to 0. And we'll go ahead and try to say that C is equal to A divided by B. Right? Actually, let's do it without a try first, see what happens. Print C. This might not actually throw an exception. Oh, it does. Zero division error. Right, there we go. So that's potentially dangerous code. Let's go ahead and surround it with a try. And I want proper 4 spaces. And then we'll print out C as we're done. Except, right? And then we'll say C is equal to 0. There's our default, right? And what's going to happen now is that we're going to divide by 0, but we won't see that exception. We'll move on with the program because all we're doing is setting a default value here to 0. And so this will end up printing 0. Should, at least. There we go. Instead of the exception. So it's basically a try, but instead of using the keyword catch like we do in Java, we use the keyword except. Right? Now, how do you print the stack trace or back trace? I think it is. What is it? Yeah, trace back. You need a library to do it. Trace back. Bring in a library, and then in your exception, we can go ahead and have a traceback, which would be what, traceback dot print exec, or exc, there we go. Then let's print another message, print error division by 0 using default of 0, dot, 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 there we go. So we'll print out an entire stack trace, we'll print out an error message, and then we'll use a default value and go on with our lives with the rest of the program. All right, there we go. So there's the trace back, but it was not a fatal error. It didn't kill the entire program. It just went on to the next line, division by 0, using a default of 0, and then it went out past the 2 blocks itself. You can catch multiple exceptions or accept multiple exceptions, except, what is it? 0 division error. There we go. And so that's what we'll do in that event. In all other events, we'll just go ahead and say print something. I don't know what happened. There we go. And let's try to cause another exception here. F is equal to open etc password, or etc shadow for reading. Let's try to open up the password file in the system, which we should not have access to, causing a file opening exception, causing this exception to occur, I think. No. Okay, well, no, sorry. This is still 0, so let's make this into 20. All right, there we go. Now that first exception should not happen. The second exception should happen. Something, I don't know what, happened. All right? The first one to actually get thrown is, and then the first one to actually match is the one that gets executed. Exact same pattern as Java and exceptions. Right? There are no checked exceptions. It is always optional to use a try catch or try except, and there is a finally. Finally, printf, do anything that needs to be done unconditionally. Right? For example, you opened up the file, it was successfully opened, you read line, 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 but then something happened in the middle of the file. You still need to close that file, for example, down here, f.close. Right? Otherwise, if an exception occurs, the file is still open and you never end up closing it, then that can be bad. File's not that big of a deal. Database connectivity, that's a big deal. You leave those open, right? You're wasting network resources. When we eventually do get to database connectivity programming, you are limited to 30 connections, 30 concurrent connections on the server. You open up 30, you never close them. That 31st one is going to kick you out. Right? So there we go. It is imperative that you clean up after yourself. Right? All right. Too fast? Too far already? No? All right, then the last 10 minutes here, let's talk about classes. Python supports classes, though is not really an OOP language. It is not really an object-oriented programming language. I don't know, when were classes introduced to Python? What version? Can we find that information? History of Python. Classes. Already present at stage in development were, okay, so it's not going to tell me. 2.2, major innovation was the unification of Python's types and classes. So Python 2.2, which was very, very close to Python 2.0. Don't quote me on this, but was there a Python 1? Like an official version 1? Yeah, Python reached, yeah, in 1994, right? Python 2, so it took them 10, 11 years, 10 to 11 years to introduce this. So it didn't really start out as an object-oriented programming language. The way that you do this is using the same word keyword def. We're going to define, we're not going to define a a function here. Instead, we're going to define a class, and let's do students, right? Don't quote me. Dang it. I always have to look up the damn thing. Oh, no, sorry. What am I doing? It's not def. It is class because it's a class definition. Student. There we go. No parentheses because that would be a function. There we go. There. All right. Sorry. So what are the member variables, right? If I wanted a student with a first name, a last name, and an NUID, in Java, I would have to declare those, right? Int, NUID, string, first name, right? ... You don't have to do that here, but you can define default values, right? For example, NUID is equal to none, right? If you don't provide me with an NUID, then the default will be none. Last name. You don't have to use none as a default. You can go ahead and use double quotes here. First name is equal to none. I'll just do John, just to show you that you can use a variety here. Right? Now, what a function? Technically, what do I want to say about that? Let's go ahead and do it like this first of all, and let's go ahead and create a student here. Me is equal to student. There, I'm going to call the constructor. Right? Now, if I tried to print myself out, print me, what is this going to print? What do you think? So in Java, if you create a class, a student class, and then you don't define the toString method, what is the default behavior of that toString method? Does anybody remember? It prints out the memory location, right? Something very similar happens here, right? It's a student object at, and then what's this thing right here? A memory address, all right? We'll talk about how to take care of that here in a second, but Python uses duck typing, right? What duck typing is, so how do you know something is a duck, first of all? This is where the term comes from. How do you know something is a duck? If it floats? Okay. I thought that this is an old idiom, isn't it? This is an old saying, isn't it? There. Yeah, if it walks like a duck, if it talks like a duck, then it's a duck, right? It doesn't matter what else it does. So is this student a duck or not? Right? Well, me dot feathers is equal to true. I can do something like that, right? What am I doing? I'm just adding a member variable here. I didn't have to do any of this stuff, right? If I want to go me dot NUID is equal to 3514 0602, I think it is. Me dot first name, right? Caveman speak. Me dot last name is equal to Bert. There we go. Now I'm a student. Why? Because I have an NUID and I have a first name and I have a last name. I didn't have to do that, right? I could have created a dummy empty object and made it into a student by giving it those properties, right? But that's not really the object-oriented programming way of doing things. So the object-oriented programming way of doing things is to properly define a constructor. So constructor, def init, underscore, self, and then in this case it'll be NUID, first name, and last name. There we go. All right, and then we'll set self dot NUID is equal to NUID, self dot first name is equal to first name, and self dot last name is equal to last name. There. That's the constructor. It is the only constructor. All right. In Java, you can have as many constructors as you want. You just name them after the class. This is not named after the class. This is what's known as a magic method. I think there's another term in Python, but in some programming languages like PHP, they call them magic methods because they're built in automatically into the language. This is an underscore. There are two underscores here, right? This is a function definition because we've got parentheses here. And it's just like regular functions outside the scope of a class, we use the def keyword here. Your argument, first argument, is always going to be self. In Java, that would be this, right? So self and this are basically the same thing. that scopes this function to this class, right? So that I can refer to myself. My NUID is equal to that NUID. My first name is equal to that first name. My last name is equal to that last name, right? Just like with the functions that we covered before, you can provide default values here if you want to. None, none. But those will end up being the default defaults anyway, right? If you want other non-default defaults, like an empty string, then you would need to use this explicit definition, right? So there's me. Let's see if that works anymore. Python demo. Nope. Why? Because I have at least one required parameter here. Remember, these two are optional because I defined defaults, right? So let's go ahead and put in 35140602. There we go. Now this should work because those default other values will take over. It's still not printing out anything meaningful to me, but at least it's working now. Now let's go ahead and put in my full name, Chris, and then my last name. There we go. Again, it's not going to change. It's going to be exactly the same as before. Note though, the memory address is changing. Why? Because the interpreter gets loaded up in a different memory location, and apparently it is relative to the system rather than to the interpreter. That is kind of odd. In Java, you would expect it to repeat the same memory address over and over and over again because it's relative to the Java virtual machine. It's all virtual memory in the Java virtual machine. And I expected that here too, but apparently it's not the case. Anyway, cool. If you want a toString method, guess what? It is another default magic method, str __ self, right? And for this, I'll just go ahead and return a formatted string here of my last name, self.lastname, comma, self.firstname, and then in parentheses here, self.nuid, formatted as a number with with at least 8 columns so that we have leading zeros. Why do we want that? How many people's NUIDs begin with a 0? At least 10% of you should have a 0. We have a small sample size in here, but okay. I hope that works because the code markup is having a problem with it, but it should work. Well, okay, fine. There's my NUID. And oops, got an extraneous. There we go. There we go. Gotta spell my name correct too. There we go. Oh, I wanted the parenthesis inside. That's what I was going for there. There we go. So magic methods. There's your constructor. There's your string. What else would you have if this were if this were Java? Like if you went up to Eclipse, generate functions. What other functions would you want to generate? Getters and setters. Do we need them here? Print me dot NUID. We don't need them here. Oh, come on. That's because it's not saved. There we go. Why? There is no strong encapsulation. There is no public, private, default, or protected, right? Instead, there's just an understanding. Generally, anything that begins with an underscore, or a single underscore, or a double underscore, those should be treated as private, and you shouldn't muck with them. That's just you shouldn't, right? It's just a guideline. It's not a rule. We don't have private NUID. Right? There is no such thing as private. Why? Because there's no strong encapsulation. So you don't need getters. You don't need setters. You can do whatever you want. Me.NUID is equal to 4 now, right? And I'll print me out again. Here, print me. There's going to be 7 leading zeros there. There we go. Why? Because of that nice little formatting right there. Okay. We'll get into more functions as we move along, but otherwise, I just wanted to introduce the syntax here for now. All right. Wednesday, and have a good time in your, I guess your lab is after this. All right.